Today, we are learning about parallel and perpendicular lines, okay? We've learned about how to graph, how to solve for coordinates, how to find the slope. Now, we're gonna solve, or in other words, label an equation to see if it's parallel or perpendicular, okay? So, there's a way to find out without even graphing the equation, okay? All you have to worry about is the slope, okay? So, let's start with the lesson. The concept for today, the title is parallel and perpendicular lines, okay? Parallel and perpendicular lines. So, like I said, parallel lines are two lines that run same direction, they never touch, okay? Usually you sometimes get two equations. For example, we might get y equals 2x plus 3. We might also get y equals 2x minus 4, okay? And we were told to graph them to find if they're perpendicular or parallel. We really don't have to really graph them. Today, we're only learning about how to identify them. So, notice that these lines or these two equations are parallel. The reason why they're parallel is notice that your slope, okay, is the same, okay? All parallel lines have the same slope. The y-intercept doesn't really matter, okay? All you need to focus on is that your slope is exactly the same, okay? That tells you that when you graph these two equations, your lines are going to be parallel, okay? So now let's move on to perpendicular lines. Our equations are y equals 3x minus 2 and y equals negative 1/3 x plus 4. Okay? The reason, or if we were to graph these two equations, they would be perpendicular to each other, okay? Meaning they were going to hit at exactly 90 degrees. So your graph is going to look something like this. At one point it hits one way, one the other. It makes that 90-degree angle. So we really don't, like I said, we don't have to graph them. All we're doing is identifying. The rule for perpendicular lines is that your slope has to be the opposite of each other. So notice that on this first equation, your slope is 3. If you recall from a previous concept, in order to graph it, we have to make it into a fraction, okay? So that fraction for that 3, always under a full number, there's a 1, okay? So we have 3 over 1x minus 2. On the other equation, notice that we have y equals negative 1/3 x plus 4. all we're going to focus on is on our slope. Here, the slope is positive. On the bottom, it's negative. Okay? They're the opposite. That's a good sign. Okay? That means that we're on the right track to identifying if they're perpendicular or not. Okay? They have to be the opposite. So one's positive, the other one negative. Notice that the first one is 3 over 1. On the opposite one is flipped. Okay? You flip your slope. So it's 1 over 3. That means that these two lines or these two equations, when you graph them, your lines are going to be perpendicular. Okay? Why? Because of the slope. They're opposite slopes. They're the opposite of each other. Okay? So notice that we really didn't have to graph them to identify if they were perpendicular or parallel. All you have to really look at is the slope on your equation. Okay? So remember, when they're parallel, the slope is exactly the same. When they're perpendicular, they're the opposite of each other. Okay? Which brings us to the assignment for today. All right, the assignment for today is you're gonna have 2 problems. You have to, for each problem, label it if it's parallel or perpendicular, okay? So, number 1, we have y equals 2x minus 6 and y equals x plus 3. Sorry about that. So for the second one, we have y equals negative 1 half x plus 3. So tell me if these two lines are parallel or perpendicular, okay? And your second example is y equals 6x plus 2 and y equals 6x minus 3. So these are your examples. Make sure you answer them as soon as you're watching the video and you submit your answers. And I'll be waiting to hear from you.